every single day, without you thinking about it, without you feeling it, without any conscious effort whatsoever. Your body runs one of the most violent and destructive chemical processes found anywhere in nature. Right now, as you watch this, there is a pool of acid sitting inside your abdomen so corrosive, so aggressively powerful, that if you poured it onto a steel razor blade, it would begin dissolving the metal within minutes. If you dripped it onto your kitchen counter, it would eat through the surface. If it touched your skin directly, it would cause immediate chemical burns. This acid sits at a pH of 1 to 2 on the acidity scale, which puts it in the same category as battery acid. The same stuff that mechanics warn you never to touch. The same stuff that destroys car paint and corrodes metal components. That acid is sitting inside you right now. It has been sitting inside you every single day of your life. And here is the question that should genuinely keep you up at night: why aren't you dissolving from the inside out? That question is not rhetorical. It is one of the most fascinating problems in all of human biology. You have an organ sitting in your abdominal cavity that is constantly filled with one of the most corrosive substances your body produces, and that organ, your stomach, is made of soft biological tissue. Tissue that, if exposed to that same acid from the outside, would be destroyed within seconds. So how does the stomach survive its own contents? How does it spend decades bathing in battery acid-level corrosive fluid without eating itself alive? And what happens when that system fails, even slightly? The answers are more complex, more elegant, and more terrifying than almost anything else your body does quietly every single day. To understand why stomach acid is so extreme, you first have to understand what it actually is and what it is designed to do. Stomach acid is primarily composed of hydrochloric acid, HCl, secreted by specialized cells in your stomach lining, called parietal cells. These cells sit in deep folds in the stomach wall called gastric glands, and their entire purpose in life is to pump hydrogen ions and chloride ions into the stomach cavity, where they combine to form hydrochloric acid. This is not a passive process. Your parietal cells actively work against a concentration gradient to push hydrogen ions into the stomach, creating an acid concentration that is roughly 3 million times more acidic than your blood. Your blood sits at a pH of 7.4, almost perfectly neutral, slightly alkaline. Your stomach sits at a pH between 1 and 2. That difference of 5 to 6 pH units sounds modest until you understand that pH is a logarithmic scale. Each single unit of difference represents a 10-fold change in acidity. So the difference between your blood and your stomach acid is not 5 times. It is not even 50 times. It is approximately 3 million times more acidic. Your parietal cells are doing something almost unimaginable on a molecular level. They are continuously manufacturing and pumping out a fluid that is 3 million times more corrosive than the blood flowing through the very same tissue that produces it. Now let's talk about what that acid is actually doing in there. Because most people have a very incomplete picture of digestion. The popular understanding is that acid breaks down food, and yes, it does. But that is only part of the story, and arguably not even the most important part. The primary function of hydrochloric acid in your stomach is not actually digestion. It is sterilization. Think about everything that enters your stomach over the course of a single day. Every piece of food you eat, every sip of water you drink, every surface you touch, and then accidentally touch your mouth with, every breath that carries airborne particles. Your mouth and food are absolutely crawling with bacteria, fungi, viruses, parasites, and other microorganisms, many of them potentially lethal if they were allowed to reach your intestines and bloodstream. Your stomach acid is the gatekeeper. At a pH of 1.5, the vast majority of pathogens that enter your stomach are killed within seconds. Salmonella, E. coli, most strains of norovirus, cholera, bacteria, all of them are extraordinarily sensitive to extreme acidity. The acid denatures their proteins, destroys their cell membranes, and essentially dissolves them before they ever get a chance to infect you. You are exposed to thousands of potentially dangerous microorganisms every single day, and you survive because your stomach is running a continuous sterilization process, powerful enough to kill most of them on contact. The third line of defense is prostaglandins, hormone-like molecules that your stomach produces to stimulate both mucus production and bicarbonate secretion. Prostaglandins are essentially the managers of the stomach's self-protection system. They receive signals about the state of the stomach environment and respond by ramping up or dialing back the protective mechanisms as needed. They also regulate blood flow to the stomach wall, ensuring that the cells have adequate oxygen and nutrients to keep up their constant rapid turnover. And here is where one of the most important public health warnings in modern medicine becomes crystal clear: non-steroidal anti-inflammatory drugs. NSAIDs, the category that includes ibuprofen, aspirin, and naproxen, work by inhibiting prostaglandin production. That is their mechanism of action. They reduce prostaglandins to reduce inflammation and pain. But when you reduce prostaglandins, you don't just reduce inflammation, you also reduce mucus production. You reduce bicarbonate secretion. You reduce the blood flow to the stomach lining. You reduce the rate of cell turnover. You partially dismantle every single one of the stomach self-protection systems simultaneously. Take ibuprofen occasionally for a headache, and your stomach's defenses recover quickly. Take it daily for months for chronic pain, or take it on an empty stomach repeatedly, and you are giving hydrochloric acid at pH 1.5 direct access to stomach wall tissue with its defenses partially stripped away. This is how peptic ulcers form. Not because the acid suddenly gets stronger, because the protection gets weaker. When the mucus barrier fails, whether from NSAIDs, from a bacterial infection called Helicobacter pylori, which actually evolved to survive stomach acid by burrowing into the mucus layer itself, or from chronic stress, which suppresses prostaglandin production, the acid reaches the actual stomach wall. And when it does, it begins doing exactly what you would expect acid at pH 1.5 to do to biological tissue. It starts digesting it. The lining erodes. An ulcer forms a raw, open wound on the inside of your stomach wall, being continuously bathed in acid. The pain from a stomach ulcer is described by patients as a gnawing, burning, drilling sensation deep in the abdomen. Some ulcers bleed slowly and chronically, causing gradual iron deficiency anemia without the person ever knowing. Some perforate completely, creating a hole through the stomach wall into the abdominal cavity, which is a life-threatening surgical emergency. All of this from the moment the protection fails and the acid gets direct access to tissue. It was never supposed to touch tissue that the acid has been kept away from by a 0.5 millimeter of gel and a continuous supply of bicarbonate ions every minute of your entire life. And the fact that this system works as well as it does, the fact that most people go their entire lives without ever developing an ulcer, without their stomach ever digesting itself, without the entire extraordinary biochemical balancing act ever failing catastrophically, is genuinely one of the most underappreciated miracles in all of biology. You are walking around every day with battery acid in your abdomen, kept in check by a layer of gel thinner than a human hair, replaced every 72 hours, managed by hormones, neutralized by a continuous stream of bicarbonate, all running silently, automatically, without a single conscious thought on your part. Every meal you eat, every glass of water you drink, every pathogen that enters your stomach and gets annihilated before it can reach your bloodstream, all of it depends on this system working perfectly, and it almost always does. The stomach is not fragile. It is not delicate. It is one of the toughest, most chemically aggressive, most constantly self-renewing environments in the entire human body. It just does its work so quietly, so invisibly, so automatically that you never think about it. Until now. The acid also does something else that almost nobody talks about. It activates your digestive enzymes. Your stomach produces a protein-digesting enzyme called pepsin, but it doesn't produce pepsin in its active form. That would be dangerous. Instead, it produces an inactive precursor called pepsinogen. Pepsinogen is harmless on its own. It doesn't digest anything, but when it encounters the extreme acidity of your stomach, the acid cleaves off a portion of the pepsinogen molecule, converting it into active pepsin. This is an elegant safety mechanism. The enzyme that digests protein only becomes functional once it hits the acid environment. And once it's active, pepsin begins breaking apart the proteins in your food, unfolding the long protein chains, and cleaving them into smaller peptide fragments that can eventually be absorbed. Without the extreme acidity, This activation doesn't happen properly. Without proper pepsin activation, protein digestion fails. This is one of the reasons people who take acid-suppressing medications long-term often develop protein absorption problems. They've reduced their acid levels to a point where pepsinogen conversion becomes incomplete, and their protein digestion becomes chronically inefficient even if they're eating plenty of protein. But we still haven't answered the central question. The stomach is producing hydrochloric acid at a pH that dissolves metal, kills bacteria on contact, and denatures proteins in seconds. How does the stomach wall itself survive this? How does the tissue that makes the acid not get destroyed by the acid it makes? The answer is one of the most sophisticated biological engineering solutions in the entire human body, and it operates on multiple simultaneous levels. The first and most critical line of defense is mucus, but not the kind of mucus you're thinking of. This is not the thin, watery mucus in your nose. The mucus coating your stomach wall is a thick, dense, almost gel-like substance secreted by specialized goblet cells and surface epithelial cells throughout the stomach lining. This mucus layer sits between the acid in the stomach cavity and the actual cells of the stomach wall, creating a physical chemical barrier. It is approximately 0.5 millimeter thick. That sounds tiny, but on a cellular scale it is an enormous distance. The mucus is predominantly made of large glycoprotein molecules called mucins, which form a tightly cross-linked gel network. Hydrogen ions, the acidic component of hydrochloric acid, diffuse extremely slowly through this gel. By the time they travel from the stomach cavity through the mucus layer toward the stomach wall, they have been significantly neutralized. And here is the brilliant second part of this system. The cells underneath the mucus layer are simultaneously secreting bicarbonate ions directly into the base of the mucus layer. Bicarbonate is an alkali. It neutralizes acid. So what you have is a continuous acid gradient across the mucus layer, extremely acidic on the stomach cavity side, nearly neutral on the cell wall side, maintained dynamically in real time, constantly, every minute of every day. The cells making the acid are sitting behind a wall that keeps them at near neutral pH, even while the cavity above them is filled with something strong enough to dissolve metal. The second line of defense is the stomach cell turnover rate. Even with all that protection, the stomach cells that face the acid environment take damage, constantly. So your body doesn't try to make those cells last forever. Instead, it replaces them at a rate that is almost impossible to comprehend. The entire surface layer of your stomach lining is replaced completely every 2 to 3 days. Every 2 to 3 days, every surface cell in your stomach that has been sitting there exposed to the acid environment is dead and gone, and replaced by a fresh new cell from beneath. Your body doesn't build a stomach lining that can withstand the acid indefinitely. It builds one that can withstand it for a few days, and then it replaces it continuously for your entire life. Your stomach lining right now is less than 3 days old. The one you'll have next week doesn't exist yet. This constant renewal is what allows the stomach to survive long-term exposure to an environment that would destroy any static material.